Imagine standing outside on a perfectly clear day. The midday sun is bright, shining down, and then, over a matter of minutes, the light is wiped out. The sky goes dark. Without the sun's rays, the temperature around you drops fast. Birds stop singing, thinking it's time to sleep. It feels completely unnatural. For thousands of years, people thought this sudden darkness was a terrifying omen. But today, we know there's no monster eating the sun. It is a massive, highly predictable trick of light. To understand exactly how the solar system pulls off this magic trick, we have to start by looking at something ordinary, a simple shadow. This diagram shows a single bright light. When it shines on this sphere in a dark room, it projects a distinct shadow right behind it. If you look closely at that shadow, you'll see it has two parts. The deep, dark cone right in the center is called the umbra. If you stood inside this area, the sphere would completely block the light source. Surrounding the umbra is a softer, lighter outer shadow. This is the penumbra. Stand here and the light is only partially blocked. These geometric rules govern a small ball in a dark room, and they govern planets and moons floating in space. This diagram reveals how that shadow play looks on a cosmic scale. When the sun, moon, and Earth align perfectly during a new moon, the moon gets directly in the way of the sun's light. Because the moon is so much smaller than the Earth, its umbra is extremely narrow. It creates a tiny dark dot that races across the planet's surface as everything moves through space. If you happen to be standing exactly inside that fast-moving dot, you witness a total solar eclipse. The moon perfectly covers the sun's bright face, revealing the glowing atmosphere hidden underneath, called the corona. If you're standing further away, inside the lighter penumbra, you experience a partial solar eclipse. The sun simply looks like a bright yellow crescent. Sometimes, the moon's orbit takes it slightly further away from Earth. When it lines up then, its umbra isn't quite long enough to reach us. It leaves a bright ring of fire around its dark edges, creating an annular eclipse. Because parts of the extremely bright sun are still visible during partial and annular eclipses, you have to protect your eyes using certified special solar glasses to look at them safely. A solar eclipse is a highly localized, fleeting event. You have to be in the exact right place on Earth at the exact right minute to catch it. Now, let's swap the positions of the Earth and the Moon. When they align with the sun during a full moon, our planet sits squarely in the middle. Earth is massive compared to the moon, which means its umbra is massive too. It easily swallows the entire lunar surface. Because of this scale, anyone on the nighttime half of our planet can watch it happen for hours. You might expect the moon to go completely pitch black inside that giant shadow, but instead it does something entirely different. While the solid Earth blocks the direct sunlight, our planet's atmosphere catches the beams skimming the edges. The atmosphere bends the light inward, filters out the blue colors, and projects a deep red glow straight into the shadow. That red light washes over the lunar surface, creating a blood moon. And because this is just gentle, reflected sunlight, you can safely watch the entire event with your naked eyes. Instead of a fast, localized blackout, a lunar eclipse is a long, slow spectacle where half the world looks up together to see the moon lit by the glow of every sunrise and sunset happening on Earth all at once. This split-screen comparison shows the stark contrast. On one side, a minutes-long daylight event caused by a tiny moon, and on the other, an hours-long nighttime event painted by a giant Earth. Both phenomena rely on the sun, Earth, and moon hitting a precise mark in the vastness of space. It is a highly intricate orbital dance, but that dance is constantly shifting. Year by year, the moon is slowly drifting away from Earth, widening its orbital path by a little more than an inch annually. As the moon moves further out, it will eventually appear too small in our sky to completely cover the sun. When it reaches that distance, total solar eclipses will simply stop happening. That means the perfect eclipses we witness today are not permanent fixtures of the sky. We happen to live in the right sliver of time to see them. Every time a shadow falls across the Earth, or the moon turns a brilliant red, the invisible mechanics of the solar system reveal themselves. It's a fleeting reminder of the silent, moving harmony happening right above our heads.